Well, students, hope all of you are very much fine at your home. So today we are going to start with the second part of S block element, that is group 2 elements known as alkaline earth metals. So let us start with the general electronic configuration of alkaline earth metals. So they have 2 electrons in the valence s orbital, that is ns2 in case of alkaline earth metals. Now coming to the electronic configuration of alkaline earth metals. So as you know that the general electronic configuration is ns2. So as you proceed down the group, there is an increase in the number of outermost shell, but the inner core configuration goes to be changed. Outer configuration will remain the same, that is ns2. So starting with beryllium, then magnesium, then calcium, strontium, barium and radium. So these are the elements belongs to group 2. So how to remember or memorize these elements? There is one trick. You can say that it is beta mange car scooter baap razi. Beta mange. So in order to memorize the elements of groups 2, there is one trick, that is a beta mange car scooter baap razi. So how you can remember? By just remembering that beta mange car scooter baap razi. So Be stand for beryllium, then magnesium, calcium, strontium, barium, then is the radium. So that is how you can memorize the elements of group 2. So in order to write down the electronic configuration, the outer electronic configuration is 2s2. The outer electronic configuration is, that is ns2. So in case of beryllium it is 2s2, then 3s2, 4s2, 5s2, 6s2, then is 7s2. There is only change in the inner core configuration, that is inner orbitals are completely filled. Now that is all about the electronic configuration of group 2 elements. So let us proceed further towards the atomic and the ionic properties of the alkaline earth metals. So first of all, let us talk about the atomic and the ionic radii. So as you proceed from left to right in a period that we discussed earlier also, atomic size goes to be decreases. So alkaline earth metals, they are smaller as comparison to the alkali metals. Similarly, as you proceed down the group, the atomic size that goes to be increases. So as you proceed from beryllium towards radium, so there is increase in the atomic as well as ionic radii. So the reason is the nuclear charge increases, but the increase in the number of shell outweighs the increase in the nuclear charge. Therefore down the group atomic size goes to be increases. So if we do the comparison with the alkali metals, so alkali metal, if we compare it with the alkali metals, it is smaller as comparison to the alkali metals. Now next property of the alkaline earth metal is the ionization enthalpies. So it depends upon the size. So they are smaller as comparison to alkali metals. So they have a high ionization enthalpy as comparison to alkali metals, but they have a low ionization enthalpy overall as comparison to the respective period elements. So we can say that general alkaline earth metals, they have a low ionization enthalpy because of the larger size, and down the group as the size increases, ionization enthalpy again goes to be decreases down the group. So as I told you earlier, the first ionization enthalpy of alkaline earth metals are higher as comparison to alkali metal. The reason is due to the smaller size. But here there is a very interesting thing that you have to note down, that second ionization enthalpy of the alkaline earth metal, that is smaller as comparison to alkali metal. The reason is after the removal of one electron, the second electron removal will be more easier, because after removing of this electron, it will acquire a stable noble gas configuration. So that is the reason second ionization enthalpy of alkaline earth metal, that is smaller as comparison to the alkali metal. So that is the important points regarding the ionization enthalpies of the alkaline earth metal. Next important property that is to be called is the hydration enthalpies of the alkaline earth metals. Again, as we discussed during your previous slides, so next important properties of alkaline earth metal, that is the hydration enthalpy. Now hydration enthalpy, as we discussed previously during your alkali metals properties, that it depends upon the atomic size. So smaller is the size of the cation, higher is the hydration enthalpy. So beryllium, that being the smallest size cation, so having a highest hydration enthalpy. Down the group, cation size goes to be increases, so hydration enthalpy also goes to be decreases. But if we do the comparison between the cationic size of alkaline earth metal and the alkali metals, so they are smaller as comparison to the alkali metal. So that is the reason mostly the compounds of alkaline earth metals, they are existing in the hydrated form. For example, beryllium, magnesium, calcium salts are existing in the hydrated form. But on comparison with the sodium and the potassium, they can't exist in the hydrated form. Reason is due to the smaller size of magnesium and calcium as comparison to sodium and the potassium. So that is the another atomic property of the alkaline earth metals. Now let us talk about the very interesting one, that is the physical properties of the alkaline earth metals. Now physical properties about their existence. So they are silvery white in color, they are lustrous, they are soft but harder as comparison to the alkali metals. If we talk about magnesium and beryllium, you might have seen magnesium ribbon during your 10th class practical, that magnesium and beryllium both are somewhat grayish in color. Again, they have a high melting in the boiling point and higher as comparison to alkali metals due to the smaller size. So due to smaller size, they can form a strong metallic bonds. But they have a low ionization enthalpy. So they are strongly electropositive in nature. So as we move down the group, atomic size goes to be increases. So again, that electropositive character goes to be increases as you proceed from beryllium towards the barium. We are not talking about radium because it is somewhat radioactive in nature. Now next very interesting question from examination point of view, it is also important one, about calcium, strontium and barium. They will impart characteristic color to the flame. We discussed earlier about flame photometry. So similarly, calcium, strontium and barium, they will give a characteristic color to the flame, that is either brick red color in case of calcium, crimson red color in case of strontium and apple green color in case of barium. But the two elements, that is beryllium and magnesium, they do not give any color or they do not impart any color to the flame. So there is one important question from here, why beryllium and magnesium do not impart any color to the flame? The reason is both beryllium and magnesium, they are very small sized element. So as a result of this, their ionization enthalpy is very high. So as a result of this, the ejection of electron will become very difficult. So these electrons are so tightly bound to the nucleus, so the excitation cannot be possible with the help of a flame only. So that is why the beryllium and magnesium do not impart any color to the flame. Now next important property of alkaline earth metal is they have a high electrical as well as thermal conductivity. So these are typical characteristics of metals also shown by the alkaline earth metals. So these all are the physical properties of alkaline earth metals. So let us move towards next, that is the chemical behavior of the alkaline earth metal. So first of all, we are talking about chemical behavior. We are talking about reactivity towards air and water. So I want to tell you that alkaline earth metal are less reactive as comparison to alkali metals. And again, down the group, as the size increases, their reactivity also goes to be increases. So it means they are less reactive as comparison to alkali metals. So let us first of all talk about its reactivity towards air and water. So almost all the alkaline earth metals, they are combining with oxygen to form oxides, and somewhat nitrates can also be formed. So first of all, let us talk one by one. Like in case of magnesium and beryllium, both they are kinetically very inert towards oxygen. The reason is because on reaction with oxygen and water, they will form a protective oxide layer on its surface. So that prevents the further oxidation or the reaction with the water. However, if we talk about beryllium, if we burn it in the presence of air, it will give a beryllium oxide and beryllium nitride will be formed. A very burns with brilliantly, it will burn in the presence of air. Similarly, if we talk about magnesium, you might have seen magnesium ribbon, a very bright or a dazzling brilliance in the presence of air. A bright light is coming with a dazzling light. So they are more electropositive, so therefore they burn in the presence of air. Again, it will form oxide layer and the magnesium nitride will be formed. Remember, both are highly reactive. If it exposed to the air, it will form oxide layer on its surface, which is acting as a protective layer. You remember in a 10th class experiment that you have to rub the magnesium ribbon first of all with the help of a sandpaper, so that the oxide protective layer is to be removed. After that, if you try to burn it in the presence of air, it will give a dazzling brilliance light. So that is due to the formation of magnesium oxide and magnesium nitride will be formed. Now next section shown by the calcium, strontium and the barium. Again they are going to be react with air to form oxide as well as nitride. Similarly, the all oxides or simple metals are combining with water. Even it can react with the cold water to form the various hydroxides can be formed. So these are the chemical reactivity, that is the reaction reactivity towards air and water. Now next we are proceeding towards the reactivity towards a halogen. Similar, just like the alkali metals, so they are reacting with halogens, but the reaction is taking place at an elevated temperature, and the formula that is MX2 type of a halide will be formed. Where X represent any of the halogen, fluoro, chloro, bromo or a iodo. Then is the reactivity towards hydrogen. Again, all the elements except we are talking about beryllium. Beryllium will show the diagonal relationship with the magnesium, so it show anomalous behavior. So all the elements except beryllium, they are combining with hydrogen upon heating. As a result of this, metal hydride will be formed with general formula this. But for the formation of beryllium hydride, we have to use a strong reducing agent like lithium aluminum hydride. It is used as a reducing agent. It is a reducing agent. So beryllium salt combining with this reducing agent, as a result of this beryllium hydride will be formed and the various byproduct will be formed. So that is the formation of the hydride upon reaction with the hydrogen. Now let us move towards the next section, that is the reactivity towards a acid. Reactivity towards a acid. Now again, alkaline earth metals, they are combining. You have discussed these reaction in class 10th also. Alkaline earth metals combining with acid. As a result of this, metal salts will be formed and there is a liberation of a hydrogen gas. So they are mostly combining with acids to form a metal salts, and the hydrogen gas will be formed as a byproduct. Now similar, next reaction is very much similar to the alkali metals. Just like alkali metals, alkaline earth metals also used as a strong reducing agent. So they also have a very large negative value of the reduction potential. But as comparison to alkali metals, they have a less negative value. So as a result of this, their reducing power will be lesser as comparison to alkali metals. Beryllium again having a less negative value as comparison to alkaline earth metal. Again the reason is why they have a less value. However, its reducing nature is due to the large hydration energy. But in this case, ionization energy is very high because of its small size. Their electron, that is 2s electron, is tightly bound to the nucleus due to the small size. So otherwise their hydration enthalpy is very high. We are expecting that its standard electrode potential value should be more negative, but it comes out to be lesser negative as comparison to the other alkaline earth metal. The reason is due to the small size of beryllium ion. So as a result of this, it is very difficult to eject out the electron, and in spite of that, they have a very large value for the enthalpy of atomization. So that is why beryllium is a less stronger reducing agent. So let us move towards the last chemical reaction shown by the alkaline earth metal, that is the reaction with liquid ammonia. So just like alkali metals, alkaline earth metals also combine with ammonia to form ammoniated electron. And again this ammoniated electron that gives a deep blue black color solution. Again this, just like alkali metals, this ammoniated metal ion that can be again recovered if this solution is further reacted with a more amount of ammonia. Now that we discuss the uses of alkaline earth metals. So that is all about the uses of alkaline earth metals, where magnesium is used for making alloy with aluminium. Similarly, magnesium aluminium alloys that are making to use the parts of a aircraft. In spite of that, magnesium powder and in the ribbon form, it is used in a flash powder in case of bulbs and the various bombs and signals. In spite of that, milk of magnesium is used in the medicine field also. As an antacid, it is used by the name called as milk of magnesia. Similarly, magnesium carbonate, it is used as an ingredient for toothpaste. Calcium, it is used for the extraction of very metal oxide into metallic form. Then calcium and the barium, both the metals, again they are also used for removing various air impurities to create a vacuum tube. Similarly, radium salts, it is used in the radiotherapy for the treatment of the cancer. So that is all about the alkaline earth metal uses. Now coming to the chemical properties behavior, that is the general characteristics of the alkaline earth metal compounds. So first of all, we are talking about the oxides and the hydroxide of the alkaline earth metals. So all the alkaline earth metals, they will form a monoxide on combining with the oxygen. The first member, that is a beryllium oxide, that is covalent in nature, while the rest member, they will become more ionic. Remember, beryllium oxide and magnesium oxide, they both are covalent in nature, but rest of the members, they are ionic in nature. Now if we talk about the enthalpy of formation of these oxides, these are very high. It means the large amount of energy will be released during the formation of their oxides, and they are very much stable towards the heat. Now coming to the nature of these oxides, except beryllium oxide, rest one are the ionic in nature as well as they are also basic in nature. Beryllium oxide, there is a very interesting question also. Beryllium oxide is amphoteric in nature. It means they are combining with acid as well as alkali. But rest of the member, they are ionic as well as they are basic in nature. But remember, their basic character is lesser as comparison to the alkali metals. So if we have taken except beryllium oxide, all the alkaline earth metal oxides, upon its reaction with water, it will form a strongly soluble hydroxide will be formed that are basic in nature. Now if we talk about the properties of these hydroxides, so these hydroxides are highly soluble, they are thermally stable, and again their basic character that goes to be increases as you proceed down the group. So why their basic character goes to be increases? Due to the increase in the size of the cation. Now next, coming to the comparison, I told you earlier that alkaline earth metal hydroxides are less basic as comparison to alkali metal hydroxide. The reason is because of the smaller size of the alkaline earth metal cation as comparison to alkali metals. Now there is a very important question also. Justify with the help of chemical reaction the amphoteric nature of beryllium hydroxide. You have to give these reactions that beryllium hydroxide upon combining with alkali form a berylliate ion, and another as well as it can also combine with acid to form this kind of a complex. So these reactions will confirm the amphoteric nature of the beryllium hydroxide. Now let us talk about the halides of alkaline earth metals. Now except again, I am telling you again and again that beryllium salts will show exceptional behavior as comparison to their group members. Similarly, beryllium halides, except beryllium halides, all the halides of the alkaline earth metals, they are ionic in nature. But beryllium halides, that is covalent in nature? The reason is because of the smaller size of the cation.